My name is Jeremy Quinton. I'm originally from South Africa. I've been living in the UK for about the last 7 years. And I thought of a story on this morning on the way here. I got in the Northern Line and I took the wrong branch of the Northern Line, and I ended up in Charing Cross, and I should have been on the other branch, which is quite funny because my first PHP conference 8 years ago, I got on a bus and I ended up in Woolwich, so I missed the first 2 talks of that conference. So I've been here 7 years and I still can't use the public transport. So just a bit about me. I've been working with PHP since about 2003. I've done a lot of PHP applications. I'm also really interested in infrastructure and application architectures. I mentioned that I came to the PHP conference in 2007. What's really awesome is the first conference that I came to had about 50 to 100 people. It was in a university. We had one sort of lecture room. It had 1 track with 5 talks. Today we've got 3 tracks. The conference is over 2 days, and there's about 600 attendees. So to see that growth in these PHP conferences is pretty awesome. I think it says a lot about PHP as a language. I'm an open source enthusiast. Everything I'm talking about today is open source, but all the projects and most of the work I do involves open source software. And I'm also a really big fan of the DevOps culture and professional movement. So that brings me to my next slide. How many guys in the audience have heard of DevOps? Right, pretty much everyone, right? DevOps is a lot of different things to different people. But DevOps is actually broken up into sort of 4 tiers. So it's culture. It's about the culture of your organization. Automation, so automating your infrastructure with things like configuration management tools in the cloud. It's about measurement. Under measurement, we also have things like monitoring tools and sharing. I can't talk about any of these today. Maybe over beer we can discuss DevOps if you want. But I wanted to tell you a story about measurement. How I came to realize that measurement is important, why you should measure, gather application metrics. And to tell you that story, I'll tell you a bit about a web application I was working on this time last year. So I was pretty much in the firing line. I was working on a PHP application, but the PHP application was really different because it only had to scale for 3 months of the year. So we had this sort of lead time where we would build this app in a series of sprints. And then at some point, we would go live to production. So that period was probably about 6 or 7 months. We would build, and then we'd push the app to production. And then we had a short period where we could do some load testing. Now, as developers, we're really good at breaking things. So this was our opportunity to stick some load on the app and get the wheels to come off and really break it. And we're really good at that. During the load testing, no problem, we could break the app. And then we had the spike. And this is the scary bit, right? I actually lost a lot of sleep in these 3 months, but we never actually knew how much traffic we were going to get. So just to give a bit of history around this application, at the time I was working for Comic Relief. So Comic Relief are a big UK charity. One year they have an event which is Sport Relief, and then the next year they have Red Nose Day. So we could have a celebrity with 2 million followers, pop out a tweet, and bring things down. But I didn't realize it at the time, but we had no application metrics. Sorry. Also, in this period, we had multiple deployments with frequent changes. So the thing is, our requirements were changing all the time, so we didn't know the knock-on effect of those changes. But we had no application metrics, and I didn't realize it at the time. And I was at PHP UK last year, and Joe did a really good talk where he spoke about you can't optimize what you can't measure. And at the time, it really hit a chord with me because what he spoke about that day and what I'm speaking about today is what I actually needed. The subject of what Joe spoke about last time around and what I spoke about was the subject of these 2 blog posts. So the first blog post is about Flickr. From Flickr, they talk about 2 application metric types, which is counting and timing. And the second blog post by Etsy, they talk about measure anything, measure everything. And they're really honing on why measurement is important. Etsy go on to talk about measuring at 3 different levels. The first level is the network level, and the second level is the machine level. And we had both these measurements in place this time last year. So we could see how much traffic was coming in, right down to the network level. At the machine level, we could see how much CPU our, web tier was consuming, how much memory and stuff. But we didn't have application metrics. And I didn't realize at the time, but application metrics are actually the third type of metric, but they're really hard to gather. And the reason they're really hard to gather is because application metrics are specific to your business and your business requirements. And as your business requirements change, so you need to gather different application metrics. So why is measurement important? It might seem really obvious, but it helps us to better understand things. And once we can, and things in this sense is our web applications, but once we better understand things, we can go about improving them. And I think improving things is a big part of what we do as developers. How many times have you written code like 6 months ago and say, did I write that code? Was that me? And you check sort of, the commit history and, it was you. But, we want to go about improving things. So to be able to improve things, we need to, first understand them. So a really good quote about measurement, and this is pretty much where I was last year, but measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. And if you can't understand it, you can't control it. If you can't control it, you can't improve it. So to get some measurement of our web applications, in this case our PHP web applications, we need some metrics. So a metric, a definition I took from the dictionary, is simply a system or a standard of measurement. Right? So we need to put a system in place to gather some metrics. So the system I'm talking about today is something that was put together by StatsD. Joe mentioned in his keynote, but about taking different technologies and putting them together. And when you put these technologies together, you can do some really cool stuff. So at a very higher level, this is a system overview. What I'm going to do is I will go into detail on each of these, but we have our application. So our application in this sense can be a PHP application, but it's anything that can send a UDP packet to StatsD. StatsD is sitting there. StatsD is a NodeJS daemon. It's event-driven. It's got fast input and output, and that's sending the metrics to Graphite. Right? So Graphite's got 3 parts. It's got Carbon, it's got a web app, and it's got Whisper. And I'll talk about each of these in a bit more detail. So what I want to do is I want to take you through the system and how to gather application metrics using this system. So we've got different types of application metrics. And the first type of application metric we have is counting. And counting is really useful just to count an event in our web application. So counting answers, simple things like how many emails did we send over the last 10 minutes within our web application? How many users logged into the system in the last 5 minutes? How many calls have we made to a particular API? So it's really just counting events, knowing how many things are happening simultaneously. So when I showed you the example earlier, when we were doing load testing, we'd know that we would bottle out the application when we got loads of 500 errors, or we saturated the network. So the thing is, if we had the metric at that point in time, we would know that we're sending X amount of emails, how many users logging in, that kind of thing, and we would know at what point that we broke it. And then when we got the 3-month traffic spike, we could then know that when our application was getting to breaking points. So how do we go about gathering a counting metric using the system? So first off, you need a StatsD PHP client library. I've just done a basic search here on Packagist. My examples today are using the first library there. There's quite a few other libraries, but actually you'll see that what the PHP client library does is very simple. So if you really were ambitious, if you wanted to, you could write your own StatsD client library. And so an example counting metric in PHP code looks something like this. So basically, I'm creating a connection here, a UDP connection to StatsD, and then I'm instantiating an object, a StatsD client object. I'm dropping that connection in, and away we go. So to do simple counts of any event in our application, it's just simply StatsD increment and the metric name. And this metric name will appear as a bucket in Graphite, and I'll show you that a bit later. Over the wire, from the PHP client library to StatsD, it's actually really simple. It's just a little packet that has this as the name. This over here is 1, which is the value for that metric, and the C means that it's a counter metric. So if you were, sorry, so I forgot this bit. So we've got the metric name, the count value, and the metric type. So if you wanted to, if you've got StatsD set up, on the bash, on the command line, you could just echo a packet to Netcat and send that to StatsD if you're just playing around and testing. So all the PHP client library is doing is making a UDP connection and sending a packet that looks like that, so it's really straightforward. Okay, but that packet gets sent to StatsD. So just a bit about StatsD. So StatsD is built by Etsy. I'm not sure if everyone's familiar with Etsy, but Etsy are a vintage online marketplace in America where you can buy all sorts of crazy stuff. And StatsD, as I've briefly mentioned, is a network daemon that gathers and flushes metrics to a backend. It's important to also understand that StatsD does do some aggregation on the metrics for us, and I'll show an example of that a bit later on. The other thing that's really important to understand about StatsD, and this is configurable, is that it has a flush interval. So you've got this NodeJS daemon, it's aggregating the metrics, and then it flushes them out to a backend at a 10-second interval. And this is probably the most important thing and the most frequent thing that people will ask, but StatsD uses the UDP protocol. So the UDP protocol is TCP's ugly kid brother. What it means is when you send a UDP packet, you're not guaranteed that that packet's going to get delivered or in the order that that packet's going to go. But what that means is that you can send the packets a lot faster and it's a lot more performant. So if you're gathering metrics and you lose some packets, it's not the end of the world, because you can use netstat to see if any of your servers you could monitor, have we lost UDP packets, and you know that that's affected your metrics. But the key concept is that we're measuring our applications, so we don't want to affect the performance of the applications with our measuring system. So another way to think of StatsD is Sonic the Hedgehog on steroids kind of thing, but it's an event-driven framework, and it's got a lot of, I/O. So basically, it's sitting there and it's gathering packets and then pumping them out. It's doing some aggregation and then send them out to a backend. So StatsD is actually really simple. If you want to go have a look later, I've looked at the source code for StatsD. The main library part is only like almost 400 lines of JavaScript, so it's not too difficult to understand what it's doing, which is nice if you maybe want to contribute to that library or something like that. So I just had a look at the source code just to get a better understanding for myself. So you can clone it. You then need to create a configuration file for StatsD. So you copy the example configuration file somewhere, just put it somewhere, and then you can start up the Node JS daemon with, you just type node stats.js and the path to your configuration. What I haven't shown you here is how to install NodeJS on your server, but you can do that by using a package manager or configuration management tool. So just a basic sample StatsD configuration. So what I'm saying is that StatsD is listening on port 8125. It's using Graphite as a backend, and then Graphite's listening on port 2300. It's on the local host in this instance. Debug equals true. The reason I showed that is because when you're getting started out with StatsD, you can get some debug information. So when you're first starting to play with it, it'll actually output data onto the screen. So if you send it a counter metric, it'll say, I'm now tracking that metric and that kind of thing. It just helps you get started, really. Legacy namespace equals false came in, I think it's version 0.5 or 1.5 of StatsD and up. So StatsD also does some namespacing on your metrics, and I'll give you an example shortly. But if you're just getting started out with StatsD, I would recommend putting a legacy namespace onto false, because you get really nice buckets for your different metric types. If you don't, there is a bit of confusion, and there's a lot of issues raised in the project. So just in the simple JSON configuration, just stick legacy namespace equals false. Okay, so we've got half a system. So I've taken us through some code here. So that's what the code looks like to track an event in our system, to get a simple counting metric. A UDP packet goes over the wire to StatsD. StatsD is sitting there. It's doing some aggregation, and then it's flushing the metrics out to the backend every 10 seconds. So just something else that's important to understand is that StatsD also does some namespacing on our metrics. So you can see here my metric name is accounts.authentication.logins.attempted. But StatsD adds some extra namespaces. So for counter metrics with StatsD, it'll namespace it stats.counters, then it's my metric name. And it actually, I'm only sending one value to StatsD, but it's actually sending 2 buckets out to Graphite. The first one is the actual count value. So in a 10-second period, if I call this piece of code 23 times, the value that gets flushed out to Graphite is 23, but then also there are events that happen in our applications very frequently. So StatsD also does some normalization and gives you the per second rate of that event. So perhaps you are sending out tons and tons of emails. You might want to see the per second rate that's happening. Okay, so just a bit on namespacing metrics. So there's not a perfect sort of answer to this question. I've put some blog posts at the bottom here. I don't know if they're legible, but my slides will be online later. You can go have a look. But in this instance, I've got the namespace, so I've got accounts. I've got the instrumented section, which is authentication. I've then got a target noun, which is login, and then I'm a past tense verb, which is attempted, succeeded, login. So when you actually view these metrics in a graph, the actual metric name makes sense. So when you thinking of naming your metrics, up front, give it a bit of thought, maybe read the blog post, but it is something to consider. Another way to name metrics that I have seen and used a bit is you might want to have the metrics per environment. So in my example, in my load testing environment, I perhaps want this metric to actually say what environment that is. That's the product name, the subcomponent is the API, and this metric type, which is a timing metric, which I'll give you examples of, is send email response time. So, there's no hard and fast rules, but, give it some, thought up front. And then these buckets, these actual metric names then appear in Graphite, and you can get graphs from those metrics. Okay, so Graphite's the third piece of the puzzle for the system. It's written in Python Graphite. Essentially what Graphite does is it stores a numeric time series data. It's just a nice way of saying that, it collects the metrics, and you can view those metrics in nice, pretty graphs. You can render graphs of this data on demand. So what that means is if you've got metrics for a week, you could go back to last week Tuesday, or 2 weeks for that matter, last week Tuesday between 2 and 4, and view that particular metrics. And you can render the graphs on demand, which is really quite powerful. And also, Graphite has a really powerful function library. So you can apply functions to your metric types and do some really cool, crazy stuff. I'll give a couple of examples later on. Okay, so I'm going to go a little bit deeper into how to configure Graphite, because there were some pinch points for me and things I got confused about, so I thought those were worth mentioning. So if you want to implement the system when you go away after this talk, you can maybe use the slides as a reference. So the first thing in Graphite is Carbon. So Carbon is a network daemon. It's uses the twisted evented IO framework of Python, but it's configured using carbon.conf, and it acts as like this buffer. So StatsD is pumping out these metrics every 10 seconds, and this buffer fills up. And because if you've got lots of metrics, you don't want to bring the whole system to a halt. When the buffer fills up, it'll write that down to disk. The important thing is that if you do get to a point where you're sending tons and tons of metrics, the first pinch point is probably going to be Carbon, because if the buffer gets full really quickly and all of a sudden it's doing a lot of seeks on the disk, you might need to take a look at that. The configuration file is quite well documented. It's got some really good comments in it, but out the box, if you're just getting started out, you probably don't need to touch anything in carbon.conf. And then we have Whisper, and Whisper has 2 configuration files. So storageschemas.conf and storageaggregation.conf. And I'll take you through those shortly. So the other thing to understand about Whisper is that it's storing numeric time series data. So your database is fixed in size upon creation, and it's similar to design to a round-robin database. So what we have is we have a timestamp every 10 seconds, and actually the data would look something like this. So you have the timestamp and then a count value. Then you'd have a timestamp 10 seconds later with another count value. So that's how, it's at a higher level, but that's to understand how Whisper is storing the data. You also then have this notion of archive. So the Whisper file format has some metadata, so it's data about the data, and then you have different archives. So I've got archive in here because you can have as many archives as you like. 3 is generally enough, or you could go with 1, but on the next slide, the archives make a bit more sense. So in the storage schemas file, the thing to understand is that the metric will come into Graphite like this, but this configuration file has different sections. So you can have multiple patterns in the configuration file, but all it's saying is, and this is a really simple, regular expression, is catch this metric, and it's prefixed with stats. So any metric that's sent across the wire to Graphite that starts with stats, that's going to be caught. So this kind of acts as a catch-all bucket. If you're getting started out, you can do this. But if you didn't want to use the catch-all approach, you could have multiple sections in this file, and it's read from top to bottom. So the first regular expression that matches is the one that'll be used. But the most important thing about this file is configuring your retentions. So I'm saying I want to store the frequency of my data that's coming in is 10-second data, and I want to store that data for 6 hours. And so my first archive will have 10-second data for 6 hours. And then we have multiple archives. So then the next archive is 1-minute data for 7 hours. And then the third archive is 10-minute data for 5 years. So you need to kind of think, okay, well, how long for this particular counter metric, how long do I want to store some values? Another pain point is that your lowest retention of 10 seconds should match the default StatsD flush interval. If you don't, you're going to end up with some weird stuff going on in Graphite, missing data and whatever. So if you change the flush interval in StatsD, which you can do, you want to up your retention values here. But the other really important thing is that because we're using a round-robin type database, when data moves from one archive to the next, data gets aggregated, right? So when we've got 6 hours of 10-second data, data starts getting overwritten again, and it gets rolled up into archive 2. And in archive 2, we've got 1-minute data, right? So for 1-minute data, we'll have 6 data points of 10-second data. So you configure the storage aggregation using the storageaggregation.conf, and again, the file's got a similar sort of format, so it's read from top to bottom. So we're saying the pattern that ends in .count, I want the aggregation method to be sum. So what that means is when it rolls the data up from one archive to the other, you want to sum the values, because by default, Whisper uses averaging. And so if you averaged out a counter metric, it's going to lose its actual meaning. The data is going to lose its meaning. When I show you timing metrics, it's okay to average those out over time. But with counter values, that's another pinch point. So you'll actually lose the meaning of your data. There's also a thing called xfiles factor, which you configure. This file has a couple of other configuration options. Again, they are pretty well documented. There's a link to the docs here. But when you go from 10-second data for 6 hours to 1-minute data for 7 days, you only want the data to be rolled up for certain metric types if you have values at each specific point. So it's not a real good name for a configuration option because it's xfiles factor. But if I had no 10-second data over a minute period, so if I didn't have the 6 data points, it's fine. The data will still get rolled up to 1-minute data, but the value would be 0. But perhaps you've got a timing metric and you don't want to do that, so you can configure that with xfiles factor. Okay, so we have other aggregation methods too. We have average, sum, min, and max. Depending on the metric types. Min and max are used for timing metrics, and that'll make a bit more sense when I show you some slides further on. But we've taken quite a bit of a sort of a deep dive here. So this is our application metric system to gather some measurements. We're doing a counting metric, so we're incrementing a counter over the wire. That's what the UDP packet looks like. We then have StatsD. StatsD is doing a job for us. It's doing some aggregation, flushes the metrics out to Carbon. Carbon sits there, gathers the metrics, and flushes it to disk. And then those metrics are stored based on our retentions, and then they're rolled up through the, in the retentions with the aggregation file. Okay. So the real important thing to understand is that Etsy wanted to have a system in place that they can go from not knowing the answer to a question to knowing that answer really quickly. So like where I said, how many emails have we sent? Or how many times is the system doing this? We can get that answer really quickly. So once you've implemented the system, you might have to come back and make some changes to it, but from then on outwards, we can just start gathering application metrics. So that's really nice. We can just put in some code, and once we've deployed our application, we get some metrics about it. So the counter metrics continued. So here's another code sample. It's really some pseudocode. I haven't sort of fleshed this out, but I've got an authentication method. I don't even have the class declaration. Sorry, I only noticed that now when it's nice and big. But I'm basically gathering how many logins have been attempted. These are successful logins, else failed logins. So in Graphite, what you have is you have 3 different buckets for these simple counter metrics, right? And if you click on a bucket, you get a nice graph of those metrics. So we can see on the left, that's logins attempted. So the logins that have been successful are in green, and I don't know how legible that is, but there's a red line there with the failed logins. But Graphite has a really powerful feature where you can correlate data really easily. So you can just take one of these graphs and just drop it on another one, and then view metrics against one another. So when you do that, you get a graph that looks something like this. So what we have is logins attempted versus logins succeeded and logins failed. So you get a really, I'm using logins as an example, but any events that happen in your system, you can correlate them to one another really easily. Counter metrics in this example. But something that, the problem that I had last year was, we were deploying our application quite a bit. So, the knock-on effect of deploying that application, you sometimes want to know, have you broken something in your application? So, another thing you can do with StatsD is you can draw lines on graphs, right? So what I'm doing over here is, what you can see, if this graph makes sense, is that everyone was logging into the system fine. We had a couple of failed logins. Then all of a sudden, we've got a deployment, right, which is the yellow line, and all of a sudden, nobody can log into the system, right? So if you're making a big feature change and you're tracking that counter feature, if you correlate it to deployments, you can see straight away, what effect you've had on it. Then you can see, there was a period of time where, things were broken. I've deployed again. All of a sudden, everyone's able to log in again, and there's a couple of failed logins, but it's gone back down to the norm. So you've got this really visual graphs of what's going on in your application. It's really powerful. So the trick to track every release is something that took me a while to work out, but is to use the draw as infinite function in Graphite. So if you right-click on one of those graphs, you get a list of functions, and you can say draw as infinite. So as long as the counter value is larger than 1, you'll get a straight line in your graph. So it doesn't only have to be deployments. It's any other event that happens that you want to track like that. You can draw it as a straight line. So I'm just incrementing a counter here that's for deploys, but obviously, if you were tracking this event, you would probably want to do it from your deployment system. So say using Capistrano or Fing or something like that. Every time you deploy, you could do that with a simple bash command. I think some deployment systems actually have a plugin that does this for you, but that's actually what's happening at the lower level. Okay, so I've taken you through the system, and I've taken you through how to gather counter metrics, but there are other metric types. The other metric types is timing. So we can time any piece of our PHP application. We can do gauges. So gauges or gauges is basically to track an arbitrary value at a certain point in time, kind of like a petrol gauge. So if you look at your petrol gauge now, and then you looked at it in an hour's time, it would have moved. So that's another metric type you can use. Sets, So sets started out as a pull request to StatsD. I haven't used sets much myself, but sets are to get the unique items in a group. So if you wanted to see something like how many unique users are on your site, you could use sets. The important thing about sets is to make sure that your StatsD client library supports sets, because the library I showed you doesn't. But again, you could probably get what that metric looks like over the wire and do the implementation yourself. Which is actually not a bad idea for a pull request on, I just thought of that now, for that library, because that currently doesn't have sets. But sets are a fairly new metric type. Okay, so let's do some timing metrics, right? So how do we do a timing metric? Well, that's really simple. On the StatsD object, I'm just calling the start timing method. So over here, the metric that I'm tracking is a send email response time. So for a hypothetical example, let's say you're using a third-party API to trigger off a transaction email. You can go start timing, then we have some code which connects to that API and sends that email, and then end timing, right? And that'll actually send a millisecond value as a timing metric. The other way to do it with this library I'm using is you can just go timing, and so basically you would give it the metric name, and this value is in milliseconds. And again, over the wire, what does the metric look like? So we've got the metric name, the value, and the metric type is ms, which is milliseconds, but it's a timing metric. So timing metrics under the hood is the most complicated metric type in StatsD. But it's important to understand that StatsD does a lot of aggregation for us. So we send one timing metric to StatsD, but StatsD produces 9 data buckets. And those 9 data buckets look something like this. So we have stats.timers, we have the metric name, and then we've got a whole bunch of sort of statistical things. So we have the mean, we've got the lower, the upper, we've got standard deviation, we've got the mean of the 90th percentile, so the mean of 90% of the values. I think someone raised the issue that you don't actually need all of these values. So at some point they might be configurable, so you can switch some of them off and only use the ones that you need. But I mean, just to understand the timing metric. So if a set of data for a 10-second period, say these were millisecond values, the mean that it calculates for you automatically, StatsD, would be 209. So it's just the sum of the values. I think my math is right there, divided by the number of values. And then we get the lower value. So in the set of data for a 10-second period, the lower value would be 200, and the upper value would be 217. So what does this look like on a graph, though? Looks really nice. So what we have here is we can see that making a call to this API, on average over time, takes 250 milliseconds. The outer limits, the upper limits, it's close to 300 milliseconds, and the lower limits is 200 milliseconds, right? So that's really useful. So I've actually produced a graph like this. So each of those 9 metric types that I showed you would be 9 different graphs, and I've just dropped these 3 on top of one of another. But if you wanted to, you could put all 9 metrics together if you really wanted to do that. But this is where timing metrics become really important. Okay, so something's gone wrong. I need to fix that slide. But essentially, we can see that calling this API took 250 milliseconds, but then all of a sudden, there's a massive jump, and it's now taking 400 milliseconds, right? What the hell happened? So you probably want to get on the phone and start, speaking to your third-party supplier and say, hey, your API is all of a sudden, taking really long to respond. But this also probably, this is an example of sending an email, but if you're timing a piece of code and you are dependent on a third-party API, and all of a sudden, the timing spikes, you probably want to know about that, and you want to maybe question them on that, because, they've probably made a change, or, it might be something on the network. There's so many different possibilities. But in reality, as developers, we are all quite busy. We're not going to sit there staring, and watching a graph and waiting for something to happen. Well, maybe if you've got time on your hands, you can do that. But it would be nice to be notified automatically if something like this happens. So Graphite does have a really powerful API, a render API. So you can actually export data in a JSON format. So you can call the Graphite API, get the data out, and then obviously do some calculations. And so if you saw that in the previous slide, if you saw all of a sudden, I mean, in this case, we would probably set our threshold, right? So we can see, okay, on average, it's roughly 250 milliseconds. If the average goes, say, up to 325 milliseconds, because that's above the outer sort of limit, let me know about that. So we get the data out of Graphite using the render API. So the render API in Graphite is quite powerful. So it basically spits out an image. In some examples, if you change the format to JSON, you get a nice, simple sort of bit of data in JSON format. And then on the back of this, we could do some anomaly detection. So in the example where we had that spike in the timing, these are two examples of anomaly detection you could do. You could write your own anomaly detection because you've got the data in that format. But NodeJS, there's a simple check that you can use of GitHub. So you can say, this is a threshold for this metric. If it goes above this threshold, send me a warning. NodeJS has different, I'm not sure how much people know about NodeJS. It has different alerting levels. So you can have warning, critical, but, so maybe warning at 325 or critical at a certain level. Another tool to do anomaly detection is a wider system called Kale that was open sourced by Etsy the middle of last year, I think. There's a really good blog post you can go read. And part of that Kale system is Skyline, right? The blog post is really interesting because he talks about the amount of application metrics that they have. And it's something like, I think he says 250,000. So you can imagine if you've got 250,000 metrics, I think Etsy has something like 250 software engineers, so that's 1,000 metrics per engineer. You as humans, we can't sit and monitor these metrics. So this is a system that they built and that they've open sourced that can actually do the anomaly detection for you. And there's another part of the scale system called Oculus, which then does if there's I think from the way I understand it, I haven't used Skyline, but if there's a problem with this metric, correlate it to this metric, and then if there's a pattern, then send me an alert. It's quite complex. I haven't worked with it. I don't have that many metrics, so but it is if you've got an application that you start to track, that might be something you want to look at. Okay, so I've taken you through using the StatsD client library, getting counter metrics, timing metrics, told you about the other metric types. But the other cool thing that we can do with this system is we can get metrics from our log files. Okay, so there's two tools to do this. So the first tool that we can use is Logster, which again, you guessed it, is by Etsy. So it allows you to pass a configuration file and put some metrics into logs. But the other tool is Logstash. I think developers are fairly familiar. I'm not sure how many guys are using Logstash, but Logstash is the other tool that you can use. So you pass log files and you send some data to StatsD. So I'm going to give you an example of how to do that with Logstash. So Logstash has this notion of inputs with filters. So over here, my input is my Apache access log. So Apache access logs, are quite configurable in terms of what you can put in them. Fairly configurable, but you can get things like number of bytes sent for a request, response codes, all different types of things. Then with Logstash, we have the input, then we have a filter. So this is using Grok pattern matching. So Grok matches some arbitrary text to pattern. I kind of like to think of it in PHP terms like preg match, so you get your matches. So it outputs a bunch of patterns, and then my output is to StatsD. So what I'm saying is, for every response code, increment a counter based on the particular response code, right? So what does that look like in a graph? So a Graphite graph of HTTP response codes, right? So we can see essentially, we've got a nice graph using counters. We've got the number of response codes. So if all of a sudden we've got a lot of 500 response codes, or 400 for that matter, or maybe a load of redirects, we can start to do some anomaly detection on this. But the point that I'm really trying to make here is that we've got so many different log files in a simple, web application. So you've got, MySQL logs if they're switched on, any tool using Varnish if that's logging. So there's loads of different data in your log files that you can then aggregate and set out to StatsD and get some nice sort of, idea of what's going on. Also, if you're using Monolog, you could potentially log something particular to a file and then graph that out into a nice graph. And viewing your log files as graphs kind of gives you kind of a sort of a better understanding of things. So this is an example that I took from the Etsy blog post, but they're tracking the number of PHP warnings. So it's clear to see that, at about 4 o'clock something happened. All of a sudden there was a load of warnings. Then all of a sudden they came down. It sort of didn't quite correct itself, and then from here onwards, everything was okay. If you correlate this to deployments, it's kind of clear to see what happened. So somebody broke something or did something stupid, like we do. Someone came along and fixed it. Things dropped off. There was a bit of sort of, stuff going on here, and then, another deployment kind of fixed it. So we can correlate deployments to things in our log files and, start to develop sort of patterns and things that way. But really, metrics from our log files. Log files contain all types of data, so there are many possibilities. The two tools I showed you are fairly well documented. So using Logster versus Logstash, I've just given you some options, whichever you sort of read and feel comfortable with using, go with that. So another thing that's really cool about Graphite is it has this render API. And so you can click on a graph and you can go, you right click and you can say, get image URL. And basically, this actually outputs an image. So you can see here, I'm saying, give me the data for the last 2 hours until now. Make the graph 800 by 600. My target is my metric type, and then just a title for the graph. But this is really useful for building dashboards. So, you can drop that URL into an image source tag and build really nice dashboards. Or say, for example, you want to brag to one of your coworkers, you've made something really fast. You can send them a link and say, check how much faster I made something, and you actually get that graph and then see how you've improved things. But you can build really powerful dashboards. And that's something that's a key thing about DevOps is in measurement, building these dashboards and, dashboards that not only us as developers see, but the wider business can see, so, how many orders, have we got in today? Maybe you've got a line going up with that or anything like that, it's, you can build some really powerful dashboards. So Graphite also has this function library. So, a couple of functions here. So the first is timeshift. So you can use timeshift to compare today's quantity of logins versus last week, or maybe you're a startup and you want to compare, the growth rate of a particular metric to the week before. You can use timeshift to do that. As a percent, you can compare one metric as a percent of another. So I've got failed logins over, attempted logins. But Graphite does have a powerful function library. If I'm completely honest, I haven't used all the functions, but if you want to view or visualize your data in some way, you probably could go about, working that out. And it is also open source, written in Python. So if you wanted to hack a feature in there, I haven't really looked at the source code, but if you wanted to, I guess you probably could. But Graphite's, the web part. So you've kind of got these graphs that you can get on demand. So the other important thing about StatsD is that it's a pluggable system. So most of these, I've literally cut and pasted this from this link, but it's got this a pluggable system which actually uses as nodes npm, which is to plug in a module. So, some examples of these. One that Joe spoke about in his talk last year was Datadog. So Datadog's actually like monitoring as a service. So if you didn't want to send your stuff to Graphite and you wanted to use monitoring as a service, you'd still use StatsD, but that would send your metrics to Datadog. And from what I've read of Datadog, it's really powerful. You can really build some nice dashboards and do some really cool things. And you can also set up alerts inside Datadog. But you've got so many options here. You've also got StatsD as a backend because the actual figures for StatsD, I think it can do something like, it bottles out at about 42 to 45,000 metrics a second in the latest version. But if you've got a system, you know, and you're doing lots of metrics, you might want to scale out StatsD. So what you'd have is you'd have a StatsD instance, and then you'd relay to other StatsD instances. But also, I think that's the plugin that you use when you plug it into Skyline. Might be able to correct me on that. But Librato and Ganglia or other graphing tools, I think I haven't used those much. But if you know you're using that system already in your company, then you can maybe just plug StatsD into that instead of Graphite. You've also got MongoDB there, MySQL, so quite a few options. Okay, so that's it basically. So I've taken you through using StatsD and Graphite, gathering metrics, the different metric types. So just in wrapping up, you know, measure all the things. I think, you know, this time last year I wasn't using application metrics. And like I said, you know, once you use StatsD to collect data and you graph it with Graphite, you really will get a better understanding of your applications. And once you've got that better understanding, you can go about improving your applications. Okay, so the next slide didn't come up. The next slide had questions on it, or just a slide. But I think we've got some time for questions now. Another thing I just wanted to mention, I haven't done many conference talks, so I appreciate any feedback on joined in, good or bad. Don't be too harsh. But yeah, I don't know. I think that's it. I don't know if you've got any questions from anyone. There's a question over there. There's a question. There's a guy over there. Get some of this water.
Do you have a kind of estimated idea of when and when not to use it? As in, if you clutter the whole, I guess, code base, okay, you could abstract it to a certain degree, but if you're collecting too much information, does it make the application slower? I appreciate it's asynchronous.
Yeah, it's a good question. I guess it's just, you get a feel for that over time, really. So if you do have a lot of code that's then making other code unreadable, you could probably think about using something like the observer pattern to fire off the metrics, so like an event-driven thing, so you don't have too much code clutter. In terms of collecting too many metrics and the performance, you know, that it has on the system, one performance tip is that when you connect to StatsD, don't connect to it by using the host name. Use the IP address, so then you'll save some time on a DNS lookup. So that's one thing. But if you're making this quick UDP connection, if you think about the PHP, you know, model, you know, it's just executing from top, like, sort of down. So if you make, you know, one quick connection and then you fire off a whole bunch of packets, I think the effect on your application is not that big. Yeah, I think the benefit that you're going to get from this, if there was a small knock-on effect, you probably wouldn't want to worry about that too much. But obviously, you know, this is the thing. It depends on the application, really, because all our applications are different. So the other thing you can do is you can do sampling, which I haven't given an example of. The library, the PHP client library I showed you, doesn't support that, but you can actually sample metrics. So you can say only send 10% of the data that I send, only send 10% of it to StatsD. And if it's something that you can't really frequently, you can say send 0.01% of the data. So does that answer your question?
Yes, it does. Thank you.
Any more questions? Got another question there in the middle.
Hello. Okay, that's better. We were talking about how you started looking at metrics a year ago. So one of the things I'm asking is that a lot of devs think that adding metrics sounds like a nice idea, but we don't really have the time. So just to really sell it, was there anything you spotted as soon as you started tracking metrics that you wouldn't have figured out otherwise, or at least you feel you wouldn't have figured out otherwise?
I guess to answer the question really simply is that you just feel sort of more in control. You've got a better understanding straight away of what's going on, because I'm using the example of where I was last year. We had lots of traffic, and you know, I did actually lose some sleep. I was on a call for the application, and once you've got metrics in place, you just get a better understanding for fields. So when you do a deployment, you can see, okay, so in our application, we had things like donations and, lots of people registering. So as long as people can still donate on the site, as long as, I can correlate that and I can see what's going on with the payment providers, you just get a sort of better feeling and understanding. I mean, it's kind of hard to put into words, but once you start doing it, you just feel more in control. You've got a better understanding. You can go about improving things. Can't really explain it better, really, but I would say do it if you can. I mean, I spoke a bit about DevOps, the professional culture and movement, but, any question you can ask, like, how many emails have we sent, or, how many times did something happen? If someone's got a business question, you can answer it really quickly. One line of code, you can count it, or you can start timing something. So, we also had things where, we had payment providers, we had WillPay and WillPay, and I don't know how much you guys have worked with payment providers, but, generally with a payment provider, you have an IPN callback. So you send someone to like the payment provider, they make the payment, and then that payment provider makes a callback to your system. So you can straight away correlate like how many people did I send to the payment provider and how many people came back, because only once someone's paid is it like an autocomplete. And in our instance, we actually had an issue where it actually turned out to be a network issue. But the problem is that if we didn't get that IPN callback successfully, the order didn't get completed, which means people didn't get like a registration pack, and it caused quite a bit of issues. And because it was a service-oriented architecture, we had all these different bits, but actually getting that out and graphing it was fairly simple, and you just feel a bit warm and fuzzy inside. So cool. Okay, cool. There's a question over there. There's another mic over here. How much? Yeah, I think we've got about 5 minutes left. So.
See if that works.
Yeah.
Right, okay, that definitely works. Right, either out the box or via some plugin. Is there any way StatsD can take system load stats, CPU, memory? Because to be honest, to be able to overlay that with metrics that we record would be massively, massively powerful to see where the bottleneck would be into show capacity and to be able to explain to your boss how much.
Yeah, sure.
How much you'd have to invest to satisfy so many users, that kind of thing. Yeah,
you can do that. I don't know how many people have used Sensu as a monitoring system, but Sensu by default uses Graphite, and you can write your own custom checks. But with Sensu, you can output data. It actually outputs data to Graphite, so you'd be able to correlate CPU to certain things within your system. So does that answer your question? What is it called? Sensu. Yeah. So Sensu is the monitoring package. So Sensu will put your data like memory usage, CPU usage, and those kind of things into Graphite graphs, and then you can use that same Graphite instance to get metrics from StatsD, and then you could correlate them to one another. So that is possible. Does that answer your question?
Just how do you spell it?
Oh, Sensu, S-E-N-S-U. Cool. It's also open source. Yeah, it's written in Ruby though, but I think you can write custom checks though. You can write custom checks in PHP, I think, but you might have to. Another question.
Yeah, hi there. In your examples, everything was sort of being logged to a local server. How exactly do you get that data away from your servers, sort of like to your office or something? Do you know what I mean?
I'm not exactly sure what you mean. So
in your example, you're logging everything to localhost.
Yeah.
And say, for example, I've got a server farm and like 5 servers or something,
yeah, all
logging to localhost. How does all that data then get back to me?
Yeah, sure. So my examples were using localhost, but the StatsD. So let's go back first to StatsD. So the StatsD configuration file. when you make a connection from the StatsD PHP client library, you can connect to any IP address, so that IP address could be in Amazon or whatever. And then from StatsD to, that goes to Graphite, that could be on another host, and that's also configurable by IP address. Does that answer your question?
Yeah, okay, so that brings me on to my next question.
Okay.
Which was, that's fine, but what about authentication? Because obviously you're using UDP, so...
Yeah, that's a good point.
Yeah. Because
So,
I don't want to be sending all this data somewhere
yeah, of course.
Unencrypted.
So let's take an example of AWS, for example. So in AWS, you can set up a virtual private cloud. So you could set up that sort of StatsD and Graphite instance in that virtual private cloud, and then that traffic would still only be going over that like sort of network if you needed that for security reasons. So I mean, you can go read up on. I mean, that's an example there. It does. So you could secure it like that. So you're not actually sending it out over sort of a wider area. And those VPCs are quite. I mean, you can go read the security white paper from Amazon. It's quite clear. I think you've actually got a segregated part of their network, so nobody else can actually sniff the packets.
That's cool. Thanks.
Okay. Yeah, I mean, that was an example of AWS. I guess you could get that in other hosting providers, sort of your virtual sort of area. Got another question.
I think you put it on the slide, but there was a slide where you've got the stats going up and down, and then you've got some vertical lines showing the deploys, and I'm guessing you've put that on to show us. Is there a way to automatically put those on, like with your deployment script? Could you make a line go into the stats?
Yeah, so I did give an example. So some deployment tools have a plugin, but for a counter metric in Graphite, you use the draw as infinite function, and it's just a simple bash command that'll actually then put the line like in a graph, but then you need to correlate that graph to the other metric.
Sorry, what's the function called?
It's draw as infinite. My slides will be online later, so we can chat about it afterwards too, but the function in Graphite is draw as infinite, and then you need a counter metric to count that event, and then you can draw those vertical lines. But you could draw, any counter metric you can draw as that vertical line, so you could sort of track any event.
Perfect, thank you.
Okay, sure. Is that, I think I'm not sure. One more question? Okay, sure. I think we've got a bit of a break after, so if we run over, it's not.
Hi. You certainly won't have any problems selling it to me. I mean, the overall idea is great. The only question I'm thinking is, did you come across any obstacles implementing it? I mean, obviously, in a new application, that won't be an issue, but in existing applications, it's like, did you come across anything that was a pitfall or anything like that, or was it just easy?
Yeah, I mean, I think it's, some of the things, that's why I showed all the configuration files. So things to think about if you're just starting out, like I showed the storage schemas with 3 retention rates. It is a bit weird when you first look at the graphs, like there is a bit of a learning curve there. So what you could potentially do is in your storage configuration, you could say store just 1 minute data for 7 days, for example. And then change your flush interval in Graphite to 60 seconds. So you have 1 minute data. I mean, there's a learning curve with anything. A couple of years ago, like 3-4 years ago, someone chucked me onto a Drupal project, and I'd been doing PHP for like 5 or 6 years, and I had to learn Drupal. It was like, what the hell? So I think, the learning curve of Drupal is quite steep. Not maybe such a great example, but there is a bit of a learning curve. There are some obstacles. I think my slides give some basic examples. So for me, it's all about, get it up and running, maybe in a vagrant sort of like environment, mess around with it, and then sort of, prototype it, and then sort of take it further. I mean, the idea that I like about this is that, if you think of like Zen framework or Symfony framework, WordPress, Drupal, whatever your PHP application, you could get a metric on just about anything in any applications. I think, like the question earlier is, all of a sudden you might see a lot of like timing sort of things, so you might want to do something like the observer pattern or something like that, but nothing I can think of now, but if I come up with something, we can maybe chat about it. But answer your question, I think, yeah. Cool. Okay, so we're out of time. So I'm here the rest of the day. I'll hang around for a beer or two tonight, and I'm here tomorrow. So if you have any questions or anything you want to run by me, please do. And any feedback on joining in, that'll be great. Thanks very much.